In this video, we will talk about negative production externality. So the example we're going to make here is one firm that produces and pollution is a byproduct of production, and another firm that has to deal with that pollution and whose production is actually affected negatively by that. So the one example is you have a firm that pollutes that is upstream, and further downstream you have a fishery that fishes and that must pay something to depollute the water, right? Or whose fish isn't that as good as it would be if there wasn't that pollution. But let's assume there is actually a depollution cost. So for every good Q, or for every unit of good Q that firm A produces, firm B, the fishery, has to actually pay a certain amount to depollute the water. And so what we want to see again is what is the individually optimal output for firm A and what is the socially optimal output. And so you can see the analysis of externalities, whether they're positive or negative in production or in consumption, is actually always the same. Right? Is to compare what would a social planner do, what is socially optimal relative to what is privately optimal. Right? So here we have the profit functions for both firms. For firm B, we assume that its profits are constant. It's just a parameter alpha. And for firm A, the profits depend on how much that firm produces. And we assume for both firms that we have increasing and convex cost functions, which means that the cost function for each firm looks something like that. Okay, so for the with every additional unit of Q, the marginal cost of producing that and also of depolluting the water increases. That is a fairly standard property of cost functions in economics. That makes profit maximization for firm A very simple, right? So all we need to do is we need to take this equation up here, take the first derivative with respect to Q, and assume an interior solution so that the first order condition equals 0. So we have here the first derivative with respect to Q equals P minus C prime Q, and we assume an interior solution. We set that equals 0, and from that we arrive at this profit maximizing condition for firm A. So for firm A, produce an amount of Q such that equality is given or is reached. But the problem is when that externality is negative, that the profit maximizing output is actually too high. So again, when you hear then politicians saying, oh, you need to leave things to the market as much as possible, well, in some instances, that may actually be the most efficient thing to do. But when you have externalities, it clearly is not. And this has been shown in the previous examples in previous videos. And it's a theme that comes over and over again in this lecture. So what is the socially optimal output? Well, here it's very simple to determine that. We again play social planner and simply maximize the joint profit of both firms. And so here, taking the first derivative of that equation with respect to Q results in the following. So we have P minus C prime Q minus E prime Q. And again, we assume that this is that we have an interior solution, that the optimal level of Q is positive. And so then we can simply set that equals 0. So that gives us, if we rearrange that, the socially efficient level of production, which is defined by this equation. So the primes here are missing, but here you have them. Right? So here you have the marginal the marginal benefit, which is the price, and that has to equal not the individual marginal cost, but the social marginal cost. So remember, previously we had the condition P equals C prime Q comp, which was if the firm decides on its own how much it produces, whereas here, in that case, the social planner decides the amount, the optimal level. And if we want to study this, then if we want to study this graphically, we would do the following. You can see this here, this graph is taken from the textbook, but maybe let's build this up actually ourselves, because it's something that some of you may have done before, but there's definitely no harm in practicing that. So let's first look at so let's first think about how this is being done. Okay, so we have here first of all the price or marginal cost or marginal benefits on the vertical axis, and we have the quantity Q on the horizontal axis. Yeah, and then we have a demand curve that is what it is, and that is simply the marginal benefit. That won't change. That's just given by consumers' utility maximization. Here we're looking at the firm side. So the marginal cost curve is equal to the supply curve, at least a segment of it. And so for a profit maximizing firm, well, that firm will choose a level of production where the marginal cost equals the marginal benefit. Right? And that's what we know from what we would call micro 101. But that is the private marginal cost. Okay? The social marginal cost is different because that fishery suffers from that negative externality, so has an extra cost because of the pollution that firm A causes. And so therefore, for firm 2, or for the marginal cost for firm B has to be added on. Right? So in that case, firm A has a marginal cost because it produces, but firm B has a marginal cost because it has to depollute. And so the social marginal cost is the private marginal cost plus what those red arrows indicate, which is often also called the marginal damage. And so here we can also then think about what the deadweight loss is, and the deadweight loss here in this case is this triangle here. Okay, because so the deadweight loss comes from the fact that we produce at the level Q comp in a competitive market rather than at the socially efficient level Q opt, at the optimal, at the socially efficient level, right? And so from that a deadweight loss arises because on the one hand we're getting now things, we're producing more, right? And that on the other hand we have that that creates a damage to another participant in the market And the difference between the two, so the fact that we're producing more, which creates obviously a benefit for consumers, but then you have to also that damage for the producer that suffers from that. That in total is so that the total damage to the economy that's given by that is represented in that triangle. You can read more about the intuition behind that triangle in the actual in the textbook by Gruber. But that's just a very quick run through how that deadweight loss would occur.